So in the previous section of this video, clearly using the bash load generation, I wasn't able to create any issues within my Kubernetes environment. And we purely walked through the developer use case whereby the developer looked at the request flow map in form of a service map. And then the developer obviously dove into the application that had maximum throughput. And then they were led into the distributed tracing pattern, which is super important in terms of understanding the causality of a particular issue. Luckily, in that scenario, there were no issues, and the developers were able to progress the application into production system. Now, in this part of my video, I'm going to talk about the production use case, and the first asset I'm going to show you here is the alerting engine. So here, firstly, we have a few open alerts, but in order to generate more alerts, what I'm going to do here is I'm going to use my existing project and deploy a bunch of Kubernetes pods, deployments, and services, which will obviously start to bring the current number of nodes, the worker nodes within my Kubernetes cluster, to its knees. So let's get started. In order to emulate that degradation scenario, I'm firstly going to apply all my resource manifests. And my resource manifests are obviously in this directory. Let's apply them. And notice as I hit enter, it's going to traverse through each and every file, that is services, deployments, and even pods from this directory. So the first deployment has just completed, followed by another deployment. Let's keep this executing whilst I'm going to take you back into the Kubernetes production monitoring pattern, which is a health map. Now, I'm already seeing some red annotations here, and they're mostly to do with application degradations. So here it's being reported that the shopfront, stock manager, and product catalog services are not running. And this is obviously a historical violation being reported here. And same way when I hover over my second logical filter set, which is critical production applications, I'm seeing similar information here. So let's click on one of these host icons, which will take you into a contextually filtered view for that particular Kubernetes worker node. All of this is done out of the box. I haven't really configured any tags per se in my Kubernetes monitoring side of the configuration. I'm going to get rid of this host filter, and I'll take you straight away into a really unique UI, which we refer to as Kubernetes. It's basically concentric rings, and 4 of them representing a typical Kubernetes cluster. Here you have some powerful filtering mechanism that allows you to filter by namespaces, deployments, and nodes. And notice you can see across your namespaces, across your deployments, and across your nodes. What that means is when you enable this type of monitoring, you obviously need to allow a cluster role binding to a cluster administrator who is then able to deploy the New Relic Kubernetes monitoring agent as a daemon set. So daemon set basically will make sure one copy of the agent runs on each and every worker node. And that's how we are able to show you the 4 nodes clearly here in form of 4 quadrants. As you move in, you see the little pods that are supported on each node. And notice some of the nodes have lesser pods compared to the other. Unless if you're applying tames and tolerances, you will be able to control what happens with your deployments. But notice for this particular node, which is GKE Super Mario and a certain name, there is one pod which is currently showing as red. If I click on this pod, it takes me directly into the sidebar that shows me this is a critical situation for a pod. it's most likely a scenario where there is a shortage of compute resources, and it will be fixed if I simply enable another node within my cluster. But let's park this for now. The other view you have here is, let's say you want to filter your cluster view only by your application views for your application pods. So you can use the filtering capability here that allows you to pick your application pods. So let's say I'm going to pick SA frontend, SA logic, and SA web app. And now it's showing me all of these three pods, which were obviously enabled in terms of a deployment, a Kubernetes deployment object. They're all pending. Let me click on one of these pods here, and it clearly shows me a warning. I'm going to click on that warning state, and it will route me into a condition that is obviously enabled for targeting such warning states. Now, this is where to kind of deep dive into the possible issues here. I can even click into this deep dive Kubernetes dashboard. And here you get a lot of your typical Kubernetes production situations pointed out, together with your unknowns that might create a problem within your Kubernetes cluster. Firstly, we show you the resources being used across your worker nodes. And because this is a managed Kubernetes service, Amazon EKS, you don't really see data pertaining to your master node. But notice here, you have 4 nodes, 1 cluster, 3 namespaces, 14 deployments, 41 pods, and 52 containers across those 41 pods. As you scroll down, you will start to see that there are some violations already happening in terms of the volume usage. And then as you scroll down, you can see missing pods by deployment are clearly being pointed out. So let us try to fix this information. Now, some pods are pending, and this typically happens when there is a resource contention. So notice the memory consumed on your nodes is about to hit the limits. So I've allocated 3.5 GB worth of memory on my main application nodes. So what I'm going to now do is I'm going to cascade into my GCP environment and then enable yet another node. And let's see if this condition gets fixed. Now, in the absence of a monitoring capability like New Relic that looks at the physicality of a Kubernetes cluster and the logical components of the Kubernetes cluster, as in the pods, the deployments, the replication controllers, and even the services, you would be left clueless as to what the problem was. Now, while I'm enabling this 5th Kubernetes worker node, I'm going to quickly execute a little command here to see if my 5th node was provisioned. So it's clearly not deployed yet. Total size is 5. I'm just going to run a little watch command here. Let's execute this. And this will continue to execute this command every 2 seconds. And whilst that is happening, let me walk you through the alerting capabilities within New Relic. So in your cluster explorer view, you observe that there were some warnings and pending Kubernetes pods being highlighted in the center of your UI. You can notice that a lot of these alert conditions were automatically created for you because New Relic, as a thought leader in this space, understands what are your most important monitoring needs. And as soon as you deploy the Kubernetes infrastructure monitor and the pod level application agents, New Relic will trigger its recommendation alerts, which you can view in the alerting screen. So let's dive into the alerting screen here. And as soon as this view renders, you can click into alert policies and straight away see that these are your Kubernetes default alert policies. And as soon as you see what these detector conditions are, you can see that this first condition already has an open incident. And then the pod not ready, pod is not ready condition also has an open incident. Similarly, whenever there is a scenario that your Kubernetes cluster or the API server wasn't able to schedule a pod, you will also receive an open condition. The second important aspect of an alerting engine is to be able to notify across a certain channel. So you can use everything ranging from email to PagerDuty, which is pretty popular these days, XMatter, ServiceNow, Slack, which is your DevOps collaboration channel, and even any customized ticketing system can be integrated within New Relic using the webhooks integration. So let's dive back into our maps view here and see the state of the current Kubernetes cluster. And you can see that the conditions are still being targeted. And rather than using CLI to describe a particular service or a deployment and then check out the logs of each and every condition, and whenever there is an infrastructure problem, kind of executing the top command and viewing your Kubernetes resource consumption related KPIs, New Relic takes all of that cognitive load away from you and gives you ready to use production TV dashboards that show you most of your common production degradations and outages in a simple to use UI. In my next video, I will show you how to monitor Kubernetes from top to bottom, which is the application side of the Kubernetes objects and the infrastructure side of the Kubernetes architecture using New Relic in less than 15 minutes. Bye for now. Notice by this time, the fifth node is in a ready state, and you can see it down here. And if I now take you into the Cluster Explorer view, the previously pending pods are no longer in a pending state. So basically, using New Relic, I was able to detect pods in pending state and pods that were unable to schedule itself. And the challenge with this particular pod, which is still in critical stage, is that it requires SSL enablement for this pod to be able to completely set up. And that's why it's still showing as critical. But observe, these three previously pending pods are now running. And that's all I really wanted to demonstrate today from a production standpoint, where applications are kind of provisioned in a way that you don't really have too much control in terms of where they go and sit. So in some sense, they are fluid and they're just kind of floating around within the Kubernetes ecosystem. You're able to use New Relic not just for the developer use case, which is to see the flow of a transaction in terms of distributed tracing patterns. You're also able to, as a production operator, quickly see how new pods and new applications and deployments are causing unexpected states within your Kubernetes environment. As promised, in my next video, I will cover how do you deploy top to bottom Kubernetes monitoring using New Relic in less than 15 minutes.